Welcome back YouTube, Moäz Kassar here once again. And for today's video, a friend of mine sent me a problem and wanted to see how I would solve this problem. Now this is the problem. We're given information that a plus b equals 3. Given that, we need to know the value of this fraction over here. On the numerator or top side, a squared minus b squared minus 4b minus 4. And over here on the denominator, a squared minus 2a minus b squared minus 2b. So then how exactly would we go about solving that? I'll leave you a bit of time to solve it. It might look like a long and intimidating problem, but there are actually ways to break it down into simpler problems depending on how you choose to solve it. So this is how I would solve it. I would take this top part over here, subtract b from both sides. If you're going to do one thing to one side, you're going to have to do the exact same thing to the other side in order to maintain equality. And so then this becomes a equals 3 minus b. Now you can do this also with a, so you can have b equals 3 minus a. However, I just chose this randomly. And the nice thing here is that we have this a all by itself on one side, and it's equal to this expression. This means that anytime we find an a in the problem, we can just replace that with a b, which is useful considering then we will only have b's and this problem will be easier to solve. So then let me write a similar fraction down on this side. So then this would become, and then remember, you want to include parentheses around the expression, considering the fact that there's a minus sign in there could lead to some confusion. So keep the parenthesis to make sure that the entire value of a is in the place of a. So then we have 3 minus b squared minus b squared minus 4b minus 4 on the numerator, and on the denominator we have 3 minus b squared minus 2 3 minus b squared minus 2b. Now this might still look pretty intimidating, considering now you have to, you would recommend it to expand and FOIL everything out, namely 3 minus b squared and 2 times 3 minus b. However, there are simple ways of doing it. As for expanding 3 minus b squared, we can refer back to the polynomial multiplication, considering we know that 3 minus b squared is just 3 minus b and 3 minus b. Now you could FOIL this, however, in my last video I showed that the grid method is a little more organized, and I generally prefer the grid method along with some other mathematicians, and so we'll just create our grid very quickly here. So then 3 times 3, that's 9. 3 times minus b, that's minus 3b. Same thing on here. And don't forget, there are both minus signs, so that then becomes a plus b squared. And so then that becomes 9 minus 6b plus b squared. Given that, we can immediately replace the 3 minus b squared terms. So then this becomes 9 minus 6b plus b squared here, and then we have 9 minus 6b plus b squared. So now this looks so now let's try cutting this down to size, considering now we can just subtract some terms from another. For example, we have a plus b squared and a minus b squared on the numerator, and those would just cancel each other out. And the same thing with the plus b squared here and the minus b squared here. We will just use this handy little eraser tool to get rid of everything here. And let me use it over here as well. So now this problem already looks easier to solve. However, we still have one more thing to expand. This 2 times 3 minus b. This one you can just simply do expansion if you want, like 2 times 3 minus 2 times 3 specifically, and then minus 2 times minus b. So then this would be a minus 6, and then minus b. So that would just become a plus b, since the two minus signs cancel out. Oh yeah, and 2b I should say. So then let's put that in its place. Minus 6 plus 2b. So now we can also notice something else. We have this 9 and this minus 4 as whole numbers without variables on the numerator, and likewise this 9 and this minus 6 on the denominator. Also, we have minus 6b and minus 4b on the numerator, and then minus 6b plus 2b and minus 2b on the denominator. So we can simplify even further. Now I'm going to erase the plus 2b and minus 2b since they cancel each other out very nicely. And then all we're left with are 9 minus 6. We'll subtract these two simply because that would just form 3. 9 minus 6 is 3. So then we have minus 6b plus 3. Likewise, we can subtract 9 and minus 4 to just get 5. And then we'll also do this with minus 6b and minus 4b to get minus 10b. Since minus 6 minus 4 is minus 10. And so then this is where we'd want to notice something else that's interesting. If we notice on the numerator, both 5 and minus 10b can actually be divided by 5. So we can just do a 5. 5 minus 5 is 1. And 10 minus 10b minus 5 is just minus 2b. However, this time we notice down here that both 3 and 6 can be divided by 3. And so this then will be a different kind of problem. We have 3, which is divisible by 3, and minus 6, which is divisible by 3. So we'll put a 3 out here. Minus 6b minus 3 is minus 2b. And then 3 divided by 3 is just a plus 1. Now, because of a distributive property, we can tell right now that 1 minus 2b will always be equal to minus 2b plus 1, regardless of b. And so this is equal to this. Since they're just being multiplied to the rest of the numerator and denominator respectively, we can just cancel them both out. So then let's get our handy dandy eraser tool. Get rid of all this. And we are just left with a simple answer of 5 over 3. Now if you want this as an improper fraction, as I know some teachers do, we can observe that 5 is equal to 3 plus 2 over 3. the 3 over 3 can be grouped as a 1, and the 2 over 3 is the remaining portion, so that would just be 1 and 2 thirds. And that's it for this part of the video. If you enjoyed this video, please let me know how I can improve my please let me know that you liked it by leaving a like or a comment down below. And if you feel like I can improve my content, make myself a little easier to understand, please let me know. My ears are open. Also, I will also leave a link to an image of how my friend who sent me this request solved the problem. His way of solving it is a little different, but I still feel like it should be worthy of sharing. In any case, this has been Moäz Kassar, and I shall see you later. Goodbye.